C Sharma. He is the Chief of Business Development, Contracts, Stores, and Technical Services at Tata Power-DDL. He has been associated with Tata Power Delhi Distribution Limited for the last 18 years in different roles and is presently heading the functions that includes business development, stores, contracts, power system control, quality assurance, and technical services. Today, Mr. Sharma will speak on modernizing T&D infrastructure and he'll give us a reality check. So, delegates, let's welcome Mr. S.C. Sharma.
Very good session by Mr. Mirji. Thoroughly enjoyed. Very informative. Going further, I'll touch upon more on distribution side of T&D. So the first thing, whether it is a smart grid, smart grid system, smart utility system, or whatever you call, why we need this smartness? The problem basically starts from, like, if you start from the beginning, from a very simple system, it says that electricity is being generated and then it is being delivered. Now, with the time, the complexity has started creeping in. So how it makes the system more complex. Like now, today, you need a system which is not to be interrupted. You need a interruption to the level of, like in Delhi, right now we have a SAIDI of around 10 hours. Like in a whole year, on average, one consumer is seeing a outage of around 10 hours. So maintaining such a reliable system, it is not possible by earlier system of manually monitoring and then correcting the things, attending to the faults. So you need like fastness in the system. So probably this is one reason where you need to introduce smartness. Now it is up to you, like how smart you want to become, where you need to add the smart. And going for the next, I feel why you need smartness is, again, earlier our systems were like this, that you were having a demand and you are serving the demand, and then grid control was not as high accuracy as it is today. We need to have, as of today, we have a very stringent penalties for drawing more or less than the forecasted power requirement. So this is another point where we need to have a smartness in our system, that how we are calculating our demands. And the demand of consumer, say we have 1.8 million consumer, how to predict the demand? Practically impossible by manual way of doing, and to the accuracy of 2% or 1%. Even 2% becomes very high if it is a deviation of 2. So the second point comes the demand from the consumer. Third point, which I feel, is that there are a lot of PVs and renewables are coming in, and a lot of these renewables are totally dependent on weather. In fact, the demand itself is dependent on weather, and even as of today, we are not finding very accurate system of telling your weather conditions, what would be the temperature, how much demand will go down. So all this is basically the complexity, which is like one by one adding into the system. Your demand is not predictable. You are introducing renewable energy sources into the system. You are introducing the electrical vehicles in the system. Then how practically it is not possible that unless we become smart and our mean time to respond to all these things become very, very low. Otherwise, we will either we will be without power, or we would be doing a bad planning. And over and above this, there is another system which is coming as of today, is that space requirement. See, all this is to be done with the infrastructure, but going further, earlier the spaces were available. We were having a good amount of space, and this is a natural resource which is basically becoming scarce day by day. So space is one of the constraints where we have to really look into, and even with that scarcity, we have to serve our consumers. So 2-3 challenge, I will say, constraint. It is one is space, another is the cost of the system, and then going further, probably I would be discussing few more things. So with this thing, what we have done is that I have taken few examples out of it, and I would be presenting one by one, because it is practically impossible to touch upon every system of modernization, every system of smart. This is the system of ours. That this is how the distribution is there. We are taking power at 66 kV and 33 kV level and then serving to the consumer. So probably it is in 2002, 2003, the first step towards automation, modernization and the further smartness adding into the system was like, let's make our grid substations, which are at these 11 kV by 440 volt substations are unmanned substations. But when we took over from DVV in 2002, these 66 and 33 kV systems were basically manned systems where on average 8 to 10 people in all three shifts put together used to man these substations and noting down the readings and taking. It was basically noting down the readings and all those things and then taking corrective action if required during that time. So what we have done is that we have done the SCADA and then eliminated the need of manning these substations. So that was right into 2003, 2004. But for that purpose, you need a system which is low in maintenance. If frequent breakdowns are there in the system, then how a central team can attend to the breakdowns so fast? Because we were having at that time around 60 grids. Of course, today in Delhi, we have around 80 grids. So it becomes very difficult if there are frequent breakdowns that to attend to those breakdowns and maintain those systems. So going further, next thing what we have done is that we have converted from AIS to GIS. So this GIS substation was one of the things where you require low maintenance, number one. Number two, you save a lot on scarce resource of space. You can see the normal substation, which is AIS, takes a 66 kV level. It takes a space of around 80 meter by 80 meter, around 6,400 meters square. Whereas if you go for the GIS of same capacity, it would take around 1,500 meters square of space. So around 75% of the saving. Or you can say that if AIS takes just GIS takes around 25% of the space, which an AIS takes. Of course, low in maintenance, environment factors are not there. Storm, it is weather neutral type of substation. It doesn't get affected much from the weather conditions unless the water enters into the substation and damage to the things. One challenge which remains with the GIS, which is need to be discussed, is like the thing which is whenever a substation, GIS substation goes down, if there is any maintenance issue, this cannot be repaired in a very short time as in AIS substation. Say suppose in AIS substations anything happens, everything is visible and it can be corrected very fast. So it is low in maintenance but high in MTTR. That it takes mean time to repair or mean time to restore is little high because you need some of the equipment. You have to open it out and see the things, diagnose, get the equipment, and then probably repairing takes more. So that is one of the challenges with GIS substations. Going further, then we have gone for digital substation. I will just touch upon that. What is the digital substation? Basically, digital substations as of today, what we have done is that we have done away the requirement of the copper cables and all those things. Now the system is having a very smart type of cable, only one cable or two cable running from field equipment from your bay to your substations. And then you have a process bus and a station bus. So you have a process bus here where your all equipment, field equipment are connected and your relays are getting connected. And then you have a substation bus where all your bays are getting. The advantage or aspect of this type of substation is basically it is very safe, low energy, and the signals are getting transferred through fiber optic cables. You don't have to run the bunch of copper cables. It takes a lot of time, and then if there is any fault in the cables, then really becomes very difficult to find out where is the fault. So it almost the number of wires which were running from your substation to substation building to the field equipment, it becomes very low. It is like earlier instruments, like earlier pneumatic system, all the tubes and all used to run to the control room. And as of today, now the electronic signals all are coming, digital signals are coming from field equipment to control room. Energy is efficient and climate friendly, definitely, because it requires very less material. And then one of the challenge which I feel which is with this type of system is that a lot of Indianization still has to happen. All these equipment are getting imported, and there are in case anything happens to the merging unit or merging unit, we were having issues with merging unit getting heated up. So attending those things is really very challenging, and even the manufacturers, I would not say manufacturers, I would say suppliers who have supplied, they find it very difficult to diagnose and finally attend to it. So the Indianization, like Make in India, has to happen in this direction to bring the cost down, at the same time making it more robust as per Indian conditions. So let me tell you, not only in digital substations, in normal relays which are coming to India, those relays are basically meant for the environment which is very clean, and the air pollution is very low. We have a recent huge failure of the relays because of this reason, like the dust getting accumulated and moisture coming in, especially weather like today. So all these things have not been taken care of when these relays were deployed in other countries, but when it comes to India, these factors become very important. Like the regulator asked for a life of around 15 years for these relays, whereas these are able to give only a life of 3, 4, 5 years, and a huge failure that again gives a very good, very high disruption to the system. So these are the few challenges with this, but slowly we are overcoming these things. We are putting some system that where this type of dust accumulation first can be restricted, and second, the equipment has to be like that they are able to live with this type of conditions. The next which I have touched upon is basically the space requirement, because the cities like Delhi or any metro, or even for that matter any large city, we find it very difficult to have a space. Actually, if we see particularly in Delhi, there are two type of development which is coming. One development which is coming is basically from DDA and all those developers who are very systematic in designing the infrastructure and putting everything in place. There is a place for substation, there is a place for park and all those. But later on, like let's say the colonies which were developed 30 years back, they have increased the occupation level. They have increased, say, floor area ratio, floor to that total area ratio. Earlier it was 2.5 and now it is 3.5, and people make it 4. So basically there is almost 100% increase in the area which is available for any purpose, for residential or for commercial purpose. So what happens is that when there is an area, there is a requirement of power, there is a requirement of it. So the requirement has increased almost by 100% when it was initially at, and the number of ACs and all those things coming in, the requirement getting increased day by day. So we need to serve those requirements with the present infrastructure, and the space is already occupied. So how we get the space? So this is one challenge which every utility almost facing for the space. Second challenge which is coming in from the unauthorized areas, where unauthorized construction happens, leaving no space for any infrastructure for that purpose. And these people, what they do is that they start with the one-story buildings made on unauthorizedly, and then slowly the infrastructure getting developed and the things putting in place, and then there starts a multi-story building construction, and then load many-fold increase in the load. In fact, in our area, we are getting more load growth in unorganized and unauthorized areas rather than the organized areas. The load growth there may be touching around some places touching around 20 to 20. So the finding a space of putting electrical inspired infrastructure is very, very challenging. And more so, like even if you find a space, you will not find it as good as a space as it was for the normal system. So this is few of the pictures we would like to show you, that how the requirement of these load and the infrastructure is increased. And the challenges I have already discussed: the land cost, and then safety. Safety is another issue while developing a modern infrastructure. Basically, earlier almost all the lines were like overhead bare lines. As of today, almost we are not putting any bare line in Delhi. We are almost underground and aerial mensed cables because of the safety of the public. So that is the another. Then what we have done to save this space, a few of the initiatives which we have done and we have implemented in Delhi. Basically, what we have done, that normal substation, which is like a distribution substation, takes around 30 square meter of place for installing one transformer. What we have done is we have made it 2 tiers, so that the space requirements is almost 33%, and we are able to serve with the same capacity of transformer with the same number of consumers. And this particular transformer was even approved by all the statutory bodies, and this has been taken in the study done by CEA and in their guidelines also. This is a few pics where this was inaugurated by TPDDL officials and the CEO. Next initiative which we like to showcase is basically compact substations that we were having earlier. The substation where the RMU, like switching devices, separate, then you have a transformer, then you have a LT device by the side of it, and all these things were earlier the separately placed. Of course, there are advantages out of it, because the things are separately placed, you are able to maintain them properly. But now what we have done, we have made it as a unitized substation, where this is the substation drawing, which you are able to see all the three things have been merged together, and it becomes a one unit with switching on the ST side and the switching on LT side, and then your transformer. So again, the space requirements reduces a lot by this system. Another is again with switch fuse unit, transformer, and LV side MCCB. Second system, this is again another way of looking into it. The earlier one was with the dry type transformer. This is basically with the normal transformer. Again, HV, LV switchgears have been combined into one, and then it has saved a lot of space out of this. The benefit, of course, is on the space part of it, which saves a lot of. Even you can install a few more switch gears, a few more installations in the same space, whatever is available. These are few real pictures of the equipment which has been installed. Going further, what we have done is that even for weather condition, weather neutral system, and the system, a different system, what we have done is basically we have made underground system, underground substation. We also earlier had underground substations, but whenever the water used to, if there is any water or any seepage into the underground system, then it becomes dangerous for the public, and there may be a leakage into this. But right now, what this system, which is designed indigenously, and all equipment are indigenous equipment, we have done this as a submersible substation. Even the transformer is submerged into water; it will keep on supplying. So you on my right side of it, this is the substation. Inside a floor, the substation is there, and the top portion can be utilized for packaging. And in case of water, also it will keep on supplying the consumer. I'll see this is the substation which looks like from inside a very robust type of thing where in any of the unauthorized areas or any areas where you are not finding any place anywhere, you can just put in under the road, and then you can make on the top of it you can put the gratings, and all the vehicles can run over it, and now that the transformer would be inside and keep on supplying the electricity. And many countries in US, in fact in Chile also, many such installations have been done and they are successfully running. And this few have been done by us in Delhi also. This is few more picks. The advantage again I have discussed that no animal electrocution, the use of land, eco-friendly, no effect of flood and water because it is submersible, so those effects will not be there. These are indoor type of substation. That was the outdoor which we have shown. That outdoor substation where even the water and all those things can come inside. These are indoor substation. Inside building also you can have underground substations like this. So we have done few this type of installation where you are indoor and then inside underground substation has been made. These are few picks from the inside. Now space saving too, then we come to basically the using of IoT devices and what purpose we can use these devices. Basically, we have used these devices for many purposes, starting from reliability, then energy audit, then reducing the cost, reducing AT&C, and improved customer experience. So many different devices are being used into. I'll touch upon in detail one or two things. This is IoT based LV automation. What we have done is that all LV current, because generally LV is a neglected area for any utility, where the measurements and all those things are not much, but there's a lot of scope to be done there. So what we have done, basically we have installed our LV automation system on the LV lines, where the current, the voltage, and the real-time monitoring and current and voltage of the LV feeders, and then switching on off of the device. So it is a multi-faceted use. Basically, this can be used for balancing your system on real-time basis, that if you find an imbalance in the system, you can always take it and balance it. Second is that if your device has switched off because of anything, instead of like consumer calling you, you have a system available where you get this, and you can always say that yes, I have the status of the device available. And if you feel like this is safe to switch on the device, you can switch on from there. So we have installed these devices in some 200-300 substations, 200 plus substations, and very good. And we are finding it really exciting that how we have worked on the LV system, basically on the low voltage. These are few pics of these devices where we have installed it in air circuit breakers and feeder pillars to monitor their parameters, and then finally switching on or off, monitoring and control board. This is basically some of the current and voltage parameter real-time basis, which has been given, with a few real pics have been taken from the system. Again, the same type of pics. And entire system, basically, if you take from customer point of view, that the sensors give the entire information to ADMS, and then ADMS is based on the data availability. After analyzing the data, it gives a signal, gives the information to the field team through FFA, Field Force Automation System, that this is the place where we are feeling and we are facing an outage, and you need to go and rectify. This is the entire FFA. I'll take one slide only. Basically, this is the system where what happens is that whatever data is coming from the field, it is getting processed in ADMS, and automatically ADMS is able to decide through logics that where the outage has taken place or which equipment has gone faulty, and based on that, the information goes to the field team, and field team wherever it is, like based on the field team availability, that whether field team has just started the work, so the information information will not go to him, but will be going to the person or the team which is almost on the finishing of that, or which has almost made themselves available for taking the next complaint or next to work upon. So this is FFA, that field force automation, which we have. The advantage of FFA basically for the safety, that all the whatever safety thing you have to observe while carrying out the work, it is automatically populated inside the device, and the person is supposed to work as per that JS. Mean time reduction, because the faster flow of information, faster flow of the data is there, so the mean time to attend a fault is also reducing. Call rush, definitely some of the calls can be directly go to FFA in case if there is any system trouble. So that is again one of the advantages of it. So this is all from my side. We can have detailed discussion on whatever point. Thank you. Thank you, everybody.